Well, happy Monday, geometry students. This is Mr. Kosal coming at you guys. About to do something I've never done before, which is put a lesson on Canvas, video record one of my lessons. So hang with me. It's going to be one of those lessons that it's very short, it's very quick. I only have 2 examples for all of you, but I'm going to try to teach it in a way as if you were in my classroom, just with me, copying the notes down, hearing my awful jokes. You're gonna notice all my handwriting is just as bad as it is online as it is in person. So with me in my classroom right now, you can't see him, but my wife is here, my son is here, Levi's with us. So midway through the lesson, if you hear a scream, wow, couldn't have timed that any better. That'll be Levi. So yeah, there he is again. So yeah, we're gonna get to it. Folks, go ahead and get your vocabularies out. You're gonna need them today for 2 vocab terms, and you're gonna need a scientific calculator. You guys all remember me talking. This is the calculator I'm gonna be using. If you have an awesome calculator, a good calculator, great. I will even take, what do we call these again? That's right, it's a crappy calculator. So any calculator will do. If you have an iPhone or an Android, that will work as well. So I'm kind of getting mine out. I think I may have done this in class once or twice, but if you turn it sideways, come on, work with me. There's your scientific calculator. You got your sine, you got your cosine, you got your tangent. So I'll try to be showing how to get the answers with every single one of these calculators, but you know what? Let's get rolling. Let's stop wasting time. I want you to do the exact same thing that you would as if you were in class with me. I'd like you to get a piece of paper out. I'm gonna title the notes. I want these notes to be organized in your binder. Folks, I know the coronavirus is hitting these this world in this day and age, but I still got to keep teaching. So here we go, folks. Here we go. If you remember, I finished with 8.4, and that was SOHCAHTOA, sine, cosine, tangent. And I'm going to continue. I'm going to jump right into my very next lesson, which is 8.5. Go ahead and write this stuff down. It's angles of elevation and depression. That's the title today. Angles of elevation and depression. 2 vocab words for you today. 2 examples I'm going to be working through with you. I'm going to try to keep this video as short as possible. I've already been going for a little over 3 minutes. Shoot, I can get done in under 20 minutes. So let's see if we can do this. Angle of elevation. In your title, put an up arrow next to elevation, because when you're elevating, you're going up, you're rising. Elevators go up in a building. I guess you can also say they go down in a building, but we're just gonna stick with the up arrow, okay? Depression, when you're feeling depressed, you're feeling down, you're feeling low, you're feeling blue. Those are the 2 big concepts that you need for today's lesson, and you'll be okay. First vocab word, I'd like you to find it. If you don't have your vocabulary, it's cool, it's fine. Write this stuff down in your notes, and you can copy it down later. But I'd like you to find angle of elevation, because I'm going to give you the definition, and I'm drawing a picture. I think the picture is going to make more sense. Angle of elevation. It's an angle formed by a horizontal. Wow, already misspelled. A horizontal line and an observer's line of sight to an object, almost done, above the horizontal line. So from start to finish, great handwriting, right? An angle of elevation is an angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. That's Levi. He wants to be a part of this lesson. All right, picture time. We need a picture. Draw a picture. I'd like you to...
Attention, everybody, the office copier is down. Do not print to it, print to the library.
You know, that's the frustrating part about doing a lesson with a video at school. You get those announcements that just come in at the awkward times. Ugh. All right, picture time. Angle of elevation. I got to show you what this means. Go ahead and put a stick figure. That's you. That's me. That's your mom. That's your cousin. That's your friend. And we need to be looking at something above our line of sight. So let's start with our line of sight. Let's say that you are looking straight ahead. You're just staring off into the distance. Here's your horizontal line. And we need to be looking up at something. Let's put a cloud right here. Put your best rendition of a cloud. There's a cloud. Now, if we want to be looking up at a cloud, we can't just be looking straight ahead. We have to elevate our line of sight. So I'm going to draw an up arrow. And we are going to turn our head and go, woo, we're going to look at it this direction. Oh, there's a cloud. Cloud's up in the air. Maybe it's going to rain today. Either way, we are elevating our line of sight. We are elevating this angle. And this angle right here is called your angle of elevation. It could be, I don't know, it could be 34 degrees. It could be 26 degrees. It could be a really big angle where you have to look really high up in the sky. Maybe it's a 71-degree angle. But either way, you're starting at the horizontal line, the horizon, sometimes I like to call it, and you're looking up. That's an angle of elevation. Nothing too big. Once again, angle of elevation, we are looking up at something. Next vocabulary word. Let's find angle of depression. Please, please be writing this stuff down. I know it's kind of weird being at home. You're not in a classroom. Well, I don't really have to take these notes, do I? No, take them. Take these notes. Write them down. Angle of depression. I know it's weird. Folks, I'm teaching a lesson right now in a classroom of, I'm looking around. There's a ton of empty desks. My wife is sitting on the other side of the room. Levi is ripping apart a Kleenex. So, you know, that's what we got to work with. Angle of depression. Well, if angle of elevation, we're looking up at something, a cloud. Angle of depression, we got to be looking down at something. So, here's the definition. I think the picture is going to make a little more sense. It's an angle formed. There should be a space right there. It's an angle formed. Oh, first hour's over. Time for second hour. It's an angle formed by a horizontal line. It's practically the exact same definition, but I'm going to change a word or two. And an observer's line of sight, so far, exactly the same thing, to an object. Let's see, that was above. This time it's going to be below the horizontal line. Yep. All right, we need a picture. We need to be looking down at something. Let's say we're standing on a cliff. What are you doing on the cliff? I don't know. Or as a building or some tall thingy thing right there. And we're looking down at something. Let's say there's a car down here. Feel free to draw a car. I could draw a perfect car. Look at that. Look at that. Angle of depression. We obviously have to be looking down at this car because it's below our line of sight, our horizontal line of sight. There's your horizontal right there. Once again, you're just kind of looking straight into the distance. And if you want to look down at this car, you need to depress your line of sight. Up here, you elevated your line of sight. You turned your head, you turned your eyes towards the clouds in the upward motion, and that's where it is. You looked at it. This time, we need to kind of turn down, 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 down. And there it is. There's the car. I guess you're looking at the front tires of the car. This right here is your angle of depression. It could be, a 43-degree angle. It could be a 55-degree angle. It could be anything. Just keep in mind, this angle right here is your angle of elevation. This angle right here is your angle of depression. For some reason or another, I don't know why, kids always think that this angle right here is your angle of depression because they see an angle, yeah, that looks good. That's the angle of depression. No, that is not your angle of depression. Angle of depression always starts at the horizontal and goes down. So just keep that in mind. I'm gonna show you an example. I think it's example 2 where you'll see this. All right, we need an example. This is my lesson today, everybody. This is it. If you tuned in or are watching this video right now, this is all I've got. I'm gonna give you one example of angle of elevation, and I'm gonna give you a second example for angle of depression, and that's it. Then you can, go back to watching your Netflix. You can go back to sleep. Stay inside, don't get that coronavirus. All right, here we go. Hopefully you got this written down. If you need to rewind in this video, feel free to do so. All right, scientific calculators, get them ready. Example 1. Example 1. Let's go ahead and write this down. It's a lengthy word problem, but let's take it slow. At a circus, a person in the audience at ground level, what's up, Levi? Watches the high wire routine. Now, folks, I've never been to a circus. I know what the high wire routine is. It's just, acrobat that's trying to balance on a rope the width of an inch, and, they got this really long horizontal pole that, I don't know, they're balancing on a pole. A person in the audience is watching a high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet above the ground. Don't worry, we're gonna draw a picture. Every word problem needs a picture. That is 25 feet above the ground. How far is the audience member from the base of the platform? How far is the audience member from the base of the platform if the angle of elevation from the audience member to the acrobat is 27 degrees. One more time, everybody, one more time. Terrible handwriting, maybe you got it, maybe you're still catching up. At a circus, a person in the audience at ground level watches a high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet above the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member to the acrobat is 27 degrees? Okay, we need a picture. There's no way we can do this problem without a picture. So, calculators, get them ready. Let's draw a picture. We have this audience member kind of down here. And apparently there's this platform. It says something about how the audience member is at ground level. So I'm gonna put a ground right here. Maybe he's in a platform with a whole bunch of other people sitting and watching the circus, and maybe there's seats that they can sit on, but they're down here and they're at ground level. And apparently there's this platform. Let's draw a little platform. Because the high wire routine has to be up high on a wire. That's why they call it a high wire routine. And I guess the wire is, I don't know, maybe it's looking like that. So you've got this acrobat